The first patent issued in the New World was in 1646 to a man named Joe Jenks for a mill run by water for the speedy dispatch of much work with few hands. In 1957, Joe Jenks' hope of much work with few hands has become a concept called automation, often much work with no hands. From the water wheel to the wheels of tape, from the abacus to the computers, from the 70-hour week to talk of the 30-hour week. The automators call it the human use of human beings. But a Philadelphia baker from Local 6 and an MIT professor are philosophically involved with automation.
Automation. These meatheads up here, our business representatives, have done nothing about it. And they are meatheads. We're being pushed out of jobs and thrown out of jobs because of them. They knew this was coming and they've done nothing to help us.
Now, the working man doesn't need to feel that he's the only person affected by this. Because let me assure you that college professors today, even in engineering, have to retool themselves in order to teach the right kind of technical material to their students every 2 or 3 years.
Now, here is Ed Murrow.
Good evening. Automation, in its simplest form, means one machine telling another machine what to do. The simplest example, the thermostat, telling your furnace when to stop and when to start. Automation is a young, new word, heavy with promise and with problems. As a matter of fact, several people have suggested to us that it's a little too heavy for a Sunday afternoon in June. Could be. We shall see. This is the Air Force's F-100. Flies about 1,000 miles an hour. Its stabilizer could not be made as well or as swiftly without automation. This is the Giddings and Lewis factory in Fond du Lac, Wisconsin, where a magnetic tape tells a milling machine what to do to the enormous slab of aluminum. The machine uses pre-calculated data, which is processed by a computer. The tape records the intricate steps of milling and then electronically translates instructions to the tools. A table holding the stabilizer does the moving. The machine tool head remains stationary. When each tool finishes its job, the tape transmits instructions that its job is finished and causes it to rise, move off, and make way for the next tool operation. The system can control 5 machine motions and 22 auxiliary motions simultaneously. It can make straight lines, circles, spirals, parabolas, and ellipses. It can plunge, channel, and contour. It has not always been this way, even in the streamlined jet industry. 5 years ago, our cameras were in a B-47 jet factory in Wichita, Kansas, watching wings being made. It took twice as long and involved something like a dozen more people. A platoon of women marched in the template which served as a pattern by which the wing skin would be marked, not unlike a dressmaker's pattern. Next, a worker traced the design on the metal. Then, slowly and laboriously, the operator began to cut out the wing. That's the old way. Now, it is estimated that savings in the aircraft milling operation can reach 50% by this new method. And because the tape and the electronic computers which feed it are incapable of making mistakes of memory, never become fatigued, or make human errors, or stop to look at a blueprint, it can eventually save the taxpayers millions of dollars. It can also free the short supply of machine tool operators for other jobs. There is one step prior to the tapes where all the pre-calculated data is translated from drafting board to punch cards to magnetic tape. But once this job is done, the tapes can be shipped to other plants to make the same stabilizers in exactly the same manner. But tapes telling machines what to do are nothing new. This is a Wurlitzer automatic one-man band, being programmed by a perforated tape and playing songs as ancient as Bye Bye Blackbird and Babyface. A tape machine causes a machine to play music. A magnetic tape builds an airplane stabilizer. At an automobile factory in Detroit, a roll of steel is processed into one end of a machine, and 8 operations and just a few seconds later, the fluid drive housings come shuttling out of the other end. The experts call this advanced mechanization, not automation. This is what they call Detroit automation. Actually, it's a Ford factory in Cleveland. Sand and metal enter an adjacent foundry, and finished engine blocks emerge from here in a matter of 8 hours. A capacity production of several thousand units a day is possible. 2 electronic panels control the 550 tooling operations of lathes, millers, grinders, and drills as raw metal is transformed into engine. The machines are programmed and automatically adjust the tools for wear. And in the event of a break in any of the many tools, stop the operation and locate the trouble. Replacements are stored adjacent to the proper machine tool, so that the machinist can make most changes in a matter of minutes. The crankshaft, the revolving heart of the engine block, is automatically fed into this grinder, where the shaft is precision ground and polished to a tolerance of 1/1000th of an inch, simultaneously finishing the 4 main bearings. Then, this 70-pound shaft is lifted out by synchronized fingers and passed on to the next step. It requires skilled technicians to maintain such equipment, but it can run for hours without human adjustment. This is James Watt's steam engine in the Ford Museum in Dearborn. Automation, cybernetics, servo mechanism, feedback, robot machines, no matter what you call it, these are but the most recent stages of the Industrial Revolution, which began when man decided that brains could take the place of brawn. That man was not a beast of burden, but a thinking reed, whose production need not be limited to what he could do with his hands and his back and his sweat. The historians say it all began with James Watt's steam engine and the flyball governor to keep the steam feed constant in spite of the load, a continuously self-operating engine that turned. Then there was Evans' Mill, built in 1784. Evans built his mill in Philadelphia, but his principle of continuous processing is employed in this restored mill at Old Sturbridge, Massachusetts. Automation is often referred to as the continuous process of manufacturing. The Evans Mill took grain into a hopper at one end, and with a crude system of water-driven conveyors, sifted, ground, and turned out finished cornmeal, buckwheat, or rye flour. Evans, the handlers, protested Congress and asked this oppressive competition. Thomas Jefferson, an inventor, said there was nothing new about it. It was no more than the Persian wheel of Egypt and the screw of Archimedes. Another benchmark, and it is visible on every engine and assembly line since then, is Eli Whitney's, not for the cotton gin, but for his theory of the interchangeability of parts. Henry Ford proved Whitney's theory about mass production, and a few of his own, by selling almost 2 million Model Ts in a single year. Ford's production line, which brought the machine to the man instead of the man to the machine, was the culmination of the revolution fused by Watt, Evans, and Whitney, and enabled him to pay his workers $5 a day. Maybe they could buy Tin Lizzies, too. By 1957, $5 a day had become $20 a day, plus fringe benefits. But a car cost a couple of $1,000s now. The race between a half a hundred automobile manufacturers had ended up with 5 big ones selling close to 6 million cars a year. It is no cliche to say we have become a nation on wheels, and that the motor industry is basic to an economy which has given us the highest standard of living in the world. It has made big business great, and it has made labor big business. President Walter Reuther of the United Auto Workers tells this story of his first visit to an automated factory.
Several years ago, when I went through the Ford Cleveland engine plant, where they had fully automated the production of engines, and I looked over the acres and acres of automated machinery, I was asked by a management person how I liked the situation, and I told him I was very much impressed, and he says, well, but you won't be able to collect dues from all of these automated machines. And I said, you know, that is not what is bothering me. What is bothering me is how are you going to sell cars to all of these machines? And you know, we can make great progress in the production of automated equipment, electronics and all that. Still going to have to make the consumers the old-fashioned way.
Out in Detroit, representatives of the automobile companies do not choose to discuss the future of automation at this time. But the members of the UAW are not reluctant to talk about it. This was a meeting of some UAW shop stewards.
People have been displaced with machines. People have been displaced because of jobs leaving the plant, and we are not prepared to meet the change because we are not notified. I think that as responsible people, we should be notified by management from model to model. What do they anticipate? What operations are going to be eliminated? How many people will be displaced? And why is it important that we should know? We should know because we can, with an organized training program, allow people to train for the new type of machines and for the new type of work coming into these plants.
Now, none of us, and I don't think our union, kicks about the introduction of automation. We welcome it, because unless this country automates, it's going to be in rough shape in competition with other countries. The problem for us is, who pays the cost of automation? The UAW is for automation. We're for progress. But we are not for the working people who are the least able to afford it to pay the total cost of automation. And in terms of human misery and suffering, that is exactly what is going on in Detroit and in the country. For example, we have 89,000 unemployed workers in Detroit now, and the industry is going full speed. What happens when we have a letdown? What happens when we have more automation next year? How are these people going to live? It's difficult to move elsewhere. It's difficult to find a job, especially if you're an older seniority employee. That means the UAW, no matter how good it is, how strong it is, or how much money we have in the strike fund, can't solve the problem of automation alone. Thanks, Brother Chairman.
You think over here in our machine shop they've cut down, and they have, because I remember the time when 3,100 people worked in there, and they didn't get 100 motors an hour, and this included truck motors as well as passenger motors. But today they can run 125 motors per hour in there, and they have less than 900 people in that machine shop of Chrysler Jefferson. It only means one thing, that the motors are needed and they're being produced, but the men that produced them are not needed to the degree that they were before. But the fellows, by the thousands who were displaced, it's not automatically a living to them. And it gets to be worse as time goes on unless the union, the government, does something about it.
One member of Local 7 said he'd like to meet the guy who thought up this business of automation. This, of course, would require a meeting with Watt, Evans, Whitney, Archimedes, Arkwright, and Einstein, and several hundred other unavailable tinkerers. It is possible, however, to talk with one of the two men who invented the word automation. John Diebold, age 31. He designs automation equipment that manufactures everything from telephones to highways, uses computers like most of us use a stove or a typewriter.
Like the pioneers of the first industrial revolution in the 18th century, we face a world in which only one thing is certain: change, fundamental change. We're leaving the push-button age. We're entering an age when the buttons push themselves. Far-sighted people see in automation not only an opportunity to reduce operating costs, but an opportunity to create new products and new services. I think it's fair to say that automation offers as much and as great an opportunity, and a challenge and a reward as any that we've ever known in America. We're going to find that we have to reconsider our whole approach to work itself, because we will start to have more and more of our life occupied by leisure. When the 40-hour week drops to the 30-hour week, when a man leaves his station fresh and full of energy at the end of 6-hour days, when leisure time spills over from Sundays to Monday and to Friday, then for the first time in our history, we're really going to face the problem of what to do with leisure time. We have to reconsider the whole concept of whether or not work is the center of our lives and leisure a means to prepare ourselves for more work. When we start to have a large amount of leisure time, far more leisure than work, we're going to have to begin to consider whether or not we can develop a society which makes leisure the basis of culture rather than the fringe.
Charles W. Hook, chairman of the board of Armco Steel, is also concerned with people and purchasing power.
You can have the finest located plant, the finest buildings, the finest equipment and tools, but they are inanimate objects that have no economic value except as people give them value. I'd like to quote what one of the foremost labor leaders of recent years said in 1951. And here it is. He said at that time, "I do not know of a single instance when a great technological change has taken place in the United States in the past 25 years that has thrown people out of work. The Industrial Revolution that has taken place in the United States in the past 25 years," he said, "has brought into the employment field an additional 20 million people."
The labor leader Mr. Hook is quoting is another old steel man, the late Phil Murray. Without machine tools and Eli Whitney's interchangeable parts, there probably would have been no engines. But without steel, there would have been no motor industry. 300 years ago, iron was being wrought with bellows, charcoal heat, and water wheels. Then came Bessemer steel in 1856. And eventually, the hand-rolled process, where men passed it back and forth through a mechanical press. Carl Sandburg wrote, "A bar of steel is only smoke at the heart of it. Smoke and the blood of a man. Pittsburgh, Youngstown, Gary, they make their steel with men." It was hard work, and actually, some stainless steel is still being made by this hand-rolling process. One of the crucial developments of the Industrial Revolution was the continuous rolling mill. In 1957, America produces 330,000 tons of steel a day. But in the fast-trundling, highly mechanized, often automatic continuous rolling mills, there is very little of the blood of man left. The iron and the coke and the smoke are still there, but muscle no longer makes steel. Even the man in the pulpit is replaceable by punch cards in some plants, and at this Armco cold rolling mill, atomic energy has been added. This steel is passing under a nuclear source, beta rays, which invisibly and constantly controls the gauge and maintains quality. The atomic source passes electronic controls, which automatically lessens or adds pressure to the roller, thus reducing of the steel. This nuclear device is capable of in classifying every foot of steel. It logs the imperfect footage and electronically inventories the minute-by-minute production according to quality and quantity. This same device is also used in manufacturing cigarettes, paper, rubber, and even dough for bakeries. Reporter Ed Scott talks to Bill Gillespie, who has been making steel for half a century.
The steel industry as a whole used to be 12 hours only in the sheet mill. And they were 8. The open hearts were 12 hours. The laborers was 12 hours. The galvanizing was 12 hours. Well, they called it 12. They worked 11 hours in the day, turning 13 hours at night, but they just called it 12 hours. And as far as wages is concerned, for the wages, when I went to work, if we made $3 and $3.50 a day, we were wonderful. That was a good job. Those same jobs today, working under the same conditions, are worth $20. $20 right on it. We worked, out of the ordinary, I would say, and I don't see the way that they make sheet iron today, how we ever stood it, but it didn't seem to bother us. We would go home so tired that we didn't know which way home was and sit down and get a little bite to eat and run around all night, start writing the next morning, the same thing over, day in and day out. It didn't make any difference to us. We get used to it. We get hardened to it.
Do you think that the future of the man who works in the factory on the production line is doomed because of machinery?
Not completely, no. No. Brains, I don't think. I think we'll always have to have some men to do some jobs. But it would be an awful long time before machinery will eventually replace man. I read these scientific papers and read them and follow that line up and see that what it says. Look at the propellers, the jet propellers. Look at them. They're going to the stratosphere as far as they can go. 8, 9, 10. I don't know how many thousand miles they can travel a day. All right, I just read it. When I was a boy, that was foolishness for anybody to talk that way. You'd never thought of it. But if you read your papers, as I said, you will find out that there's nothing impossible.
Thank you very much, Bill.
Pick it up, Paul. You're low. Okay, you're looking good. Ease your nose up just a little bit.
One of the problems with our new super carriers, the Forrestal and the Saratoga, is that in spite of their size and range, before launching an mission, the skipper must be certain that the carrier will not be socked in by fog when the planes get back. The Navy's problem, therefore, has been to find an electronic device to land planes on a moving carrier that the pilot cannot see even at 20 feet. Up until now, the military and the commercial lines have been using automatic pilots and various instrument control approach systems. But those servo mechanisms never attempted actually to bring a plane down to a complete landing. At a given point, the pilot had to take over control of the aircraft.
You let your nose drop on that one, you hit pretty hard.
But what we are looking at now is Bell Aircraft's automatic landing system, bringing a Navy F-3D to an automated touchdown under simulated 0-0 weather conditions. Approximately 1 minute from the carrier, the pilot, completely enclosed in fog or storm, takes his hand off the stick, and automatically the landing of the aircraft is taken over by radar and computers on the ground. This parabola radar antenna tracks speed, altitude, drift, and every movement of the jet with the computer translating the flight instructions into commands, which bring the plane to touchdown. Under seagoing conditions, the system would also compensate for the roll, pitch, and yaw of the carrier. In these exercises, the pilot does take over at touchdown, but the automatic mechanism can continue the landing for another 100 feet. This equipment will soon be installed on aircraft carriers. The Air Force also has been testing the system, and the potential of such a landing device to civilian aviation gives great promise. It is expected to be able to handle anything from light aircraft to a Boeing 707 or a helicopter. Conceivably, it could alleviate the danger of holding and stacking up traffic over a fogged-in airfield by cutting holding time to a minimum. This system is capable of landing 120 aircraft an hour. As Bill Gillespie says, nothing is impossible. And this is SAGE, the Lincoln Labs near Lexington, Massachusetts, the largest magic brain in the world. This building is one immense computing mechanism and laboratory, built for the United States Air Force by IBM in conjunction with the Massachusetts Institute of Technology. We have all watched UNIVAC and Whirlwind in action, but this SAGE device is the $20 million culmination of these developments. It has been used experimentally to coordinate the air defense system of the northeast portion of the United States. Similar installations are planned for other parts of the nation. All the flight plans of commercial and military aviation, plus the radar intelligence from Texas towers at sea, picket ships and airborne detection devices, Air Force and Navy, and Ground Observer Corps, are fed into these high-speed digital computers, whose memory can store some 7 million different facts. The outdated method was to chart all friendly and unidentified aircraft with plotting boards and slide rules.
Of Bangor, 3 miles southeast of observation post, flying southwest. Check, thank you.
Now, this winking, blinking wonder, with its 25,000 tubes and its racks of high-speed tapes and millions of punch cards, and its men, hundreds of them, digests, computes, perceives, and passes everything on to a final radar screen in the command station. This is Dr. George Valley, who helped build this SAGE project and is now Chief Scientist of the Air Force.
This display console shows us the air situation. That is, it tells us immediately and at a glance and up to the second the positions of each airplane in the sky. It tells us how fast they're going, how high they're flying, and most important of all, from the point of view of air defense, it tells us their identity, whether they're friendly or hostile to us. Now let's see how SAGE keeps track of friendly airplanes. Now we are looking at the background information which the display console shows the operator of the SAGE system. You see it shows a map of the northeastern part of the United States, including the area for which this direction center might be responsible, including New York, Philadelphia, Baltimore, and Boston. And now by throwing this switch, I cause the actual positions of the airplanes to appear superimposed on the map so that we can see where each one is. Under each dot, there is a number. That is the track number by which we keep track of the particular airplane. The machine, of course, has information on the detailed character and behavior of each of these airplanes, and we can ask it questions by means of this light gun about any of the airplanes we see on the scope face. Suppose we, for instance, desire to know about track 9. By means of the light gun, I say that this is flying at about 300 miles an hour, almost due west. And the flight plan information written on the bottom of the scope says that this is Flight 151 of Pan American, and that it left Lisbon, Portugal at 1:30 this morning and is due to arrive in New York at 11:59. Not only, however, can we ask the machine for information about particular aircraft tracks, but sometimes when unusual circumstances arise, the machine will inform us that we ought to ask it about a particular track And we see that this has happened in the case of track 4 up here, where a square has been placed by the machine about the track. Since the emergency square has appeared around track 4, I shall ask the machine to tell me the characteristics of track 4. The machine replies by putting an arrow which indicates the course and speed of track 4. Indeed, it is seen to be going about 600 miles an hour, almost due south toward Otis Air Base. The particular different information about track 4, which is of importance to us, is that this is a military flight which has left Brunswick at 11:30 and which is due to arrive at Otis Air Base at 12:30.
SAGE has nothing to do with the control of civilian air traffic, but it does not take an expert to be able to comprehend the potential of such devices in regulating the already congested commercial air routes. A collision course, like that of the two transports over the Grand Canyon last summer, would have had these computers chattering and flashing their warning protests many minutes before that crash. It has been said that the really important advances in civilization occur when two sciences come together. Electronics, radar specifically, helped to save a nation during the Battle of Britain. Today, another kind of early warning device may help save an entire generation of women from the threat of cancer of the cervix, the second most frequently fatal form of that disease to females. This electronic detector, built by the Airborne Instrument Laboratories and the life work of a dedicated cancer researcher, have been joined together by automation. This is the doctor, George N. Papanicolo, Professor Emeritus of Cornell Medical College. It has been his theory, long since proved and accepted by the medical fraternity, that virtually no woman need ever die of cancer of the cervix if she would have a smear made twice a year. If the growth is detected early enough, minor surgery can eliminate it. The problem has been that only Dr. Papanicolo, or a pathologist or cytotechnician trained in his method, could interpret these slides. As Dr. Papanicolo explains it,
take into consideration that trained and skilled cytotechnicians cannot possibly examine more than 12 specimens a day. That is about, we say, 60 a week or 3,000 a year. You can figure out how many technicians are needed to study the specimens from the full female population of the United States.
even if every woman in the United States would agree to have these smears taken, it is obvious that it would be almost impossible to train sufficient cytotechnicians to read them. This cytoanalyzer, built with grants from the American Cancer Society and the Public Health Service, has learned to interpret these smears. This microscope, which is in many ways a television camera, scans the cell nuclei on the slides and transmits the information to a computer, which decides whether the cells are normal or suspicious, almost like a pinball machine saying, this machine is tilted. This cytoanalyzer will not definitely diagnose the cancerous smears, but it will automatically discard the normal ones. Dr. Papanicolo says that 90 out of 100 samples are normal. This means that only that 10%, which appears to be suspicious, would have to be sent on to a human technician. It is expected that such machines will be able to read 500 slides per day, as compared to the 12 that Dr. Papanicolo says a technician can screen. The first two prototypes are being delivered to Sloan Kettering Institute and the University of Tennessee in Memphis, where 100,000 women have already had smears made. Both Dr. Papanicolo and the inventors point out that it will take a year of field tests before these cytoanalyzers can be accepted for hospital uses. This first one cost $300,000 to develop. Sage cost $20 million. Neither of these early warning devices would have been possible without automation. There was a day when telephone switchboards looked like railroad switching yards. As this Bell system reenactment indicates, it required men and muscle and good lungs to be an operator. There were protests, of course, when female labor took over Central.
Number 2,
And in 1920, when the first dials were installed, there were vigorous protests that it would cause severe unemployment. Today, telephone use is such that had the dial not been invented, it is estimated that almost every woman in the United States would have to be employed as a telephone operator. Today, there are still operators, and many of them work in the long lines division. But recently, automation has begun to take over long distance. One of the first areas affected was northern New Jersey, where subscribers can reach over 200 cities by what is called direct distance dialing. A complicated system of relays, bars, switches, feedback, and translators place the call and route it across the country. If the route is busy, it automatically reroutes it through another regional center. It rings a number on the West Coast in a matter of seconds.
Hi, Mom. Where are you? In Englewood.
Simultaneously, computers time the call, recording all the pertinent information on tape. Not the conversation, but the duration of the call, its origin and destination. Each day, the tapes with all the information from hundreds of thousands of calls are taken to the accounting section in a nearby community. Perforated tape transposes it onto punch cards. All untouched by human hand, except for the technician who threaded the tape and fed the punch cards. Punch cards translated into dollars and cents on each subscriber's monthly bill, complete with date, rate, and of course, state and federal taxes. The phone company expects that none of this automation will contribute to unemployment, that it can absorb all the operators in other divisions. This is the Westinghouse factory in Bloomfield, New Jersey, where 5,000 light bulbs for various uses are produced every minute. The use of household gas was supposed to have doomed the candle maker, and Edison's incandescent bulb was supposed to have killed the gas industry. But we use more gas today than ever before. Semi-automation is nothing new in production of incandescent lamps. But because it is one of the most highly engineered items that the housewife can buy, it has been extremely difficult until now to construct automatic equipment to do the precise work involving the tungsten wire filaments, which are the diameter of a human hair. 35 years ago, a battalion of women and men did this with tweezers, pliers, and soldering irons. Today, in an economy of rising prices, the light bulb is one of the few staples that has not only held its own, but actually gone down in price. In 1932, the United States produced 500 million light bulbs. In 1956, almost 3 billion. In 32, a 100-watt bulb sold for 35 cents. Today, a 100-watt bulb with much more brilliance sells for only 23 cents. And more people are engaged in the industry than ever before. Now, hear this. You're looking at General Electric's experimental XPC-1. The elevator you are looking at is not carrying jets up to the flight deck of the Forrestal, but shuttling candied yams from the freezing compartment to the oven of what General Electric hopes will be Milady's programmed cooker of the future. This is the prototype model, built at a cost of more than $150,000. It is both a freezer and a stove, in which the housewife stores frozen components of the various foods she thinks her family might like to eat. Each day, she punches up the evening meal on the scheduling panel. A half hour before serving time, the electronic timers take over. At H hour minus 30 minutes, the roast pork begins its automatic journey to the UHF oven. A mechanical muscle peels back the aluminum foil. At H hour minus 15 minutes, the yams are sent into action. At H hour minus 5 minutes, the rolls move into position. When the feedback mechanism indicates that everything is ready, a chime signals the completion of this combined operation. The inventors of this cybernetic chef point out that this is not intended to replace Mom's cooking. She can still prepare the food that the machine programs if she wishes. For those who would compromise complete automation for gracious living, a push-button stove is already on the market. Meat tenderness is computed by a feedback apparatus, and when the roast signals that it is precisely succulent, the machine plays tenderly. This is a bakery in Philadelphia, where automation has become almost a swear word to the workers. To scientists, there is a wide gulf between automation and mechanization such as this. But if you've lost your job, or think you're going to, automation has become a catch-all for any machine that causes layoffs. That's bread dough, already mixed, sifted, larded, and kneaded mechanically, being lobbed into the baking pan. This is the Freihofer Bakery in Philadelphia. There is no feedback system here, and the nearest thing to automation or even electronics is a photoelectric cell, which serves as a sort of traffic cop and keeps the two lines of bread pans from colliding on the final runway to the oven. Basically, this method has been used in bakeries in the United States for the past 20 years. Freihofer makes 450,000 loaves per day here, and recently, by installing new silos for receiving and storing flour and several other new devices, it has eliminated some types of jobs. We listened to members of Local 6 of the Bakery Union.
But they never get to the humanitarian side of people who are let go by automation, what their particular problems are, what confronts them when they're let go of their jobs, when they've accumulated 15 to 20 years of seniority, when they have gone beyond the age limit of 40, according to some of the statistics. You're just as well dead at the age of 40. We don't know where it's going to end. The floor is open for any questions that may come from the floor.
As you know, I've been up there in the packing room for 16 years. I have 5 children. Now, if I'm displaced out of my position, what is going to happen to me? I know we should stick together, and I, for one, am going to do the same as I've been doing in the past. I'm not going to take any additional work upon my shoulders, and I believe that should stand for the rest of the membership in this building today.
I was there for 14 years, and I'm 44 years old. And from what I know, I understand, no place else would have going to hire me. The only place I could have go to work is picking a shovel.
Automation, automation. These meatheads up here, our business representatives, have done nothing about it. And they are meatheads. We're being pushed out of jobs and thrown out of jobs because of them. They knew this was coming and they've done nothing to help us. Yet they say they're looking out for our welfare. Are they looking out for our welfare? They're only looking out for their own pocketbook, every one of them.
I know that there's a lot of dissatisfaction because of the layoffs, and what can the union do? With a problem like this, I don't know what we can do. And while it was mentioned earlier that maybe it'd be a good idea to take the people out on strike, if that were the answer, we would be the first ones on the picket line. But that isn't the answer. Maybe some of you have some answer to it. Very frankly, we don't.
I hear a lot of talk going around up the shop. But when you come down here, you don't have a damn thing to say. Why don't you get up and say it now? A lot of you guys are doing 2 or 3 different jobs instead of refusing to do but your own job. That's one of the reasons they don't need as many men as they do. But now that it's hurting you guys is a holler like hell. Why don't you get up there and say it now?
Mr. President, I disagree with the brother that called our representatives meathead. I'm a member of the sweet dough department. And at one time, we had plenty of work until the company eliminated all hand work and got a machine and a faster machine in the belt, and now we're only putting out a cinnamon bun, and they're just cinnamon bunning the public to death.
We'll never get no place if we're going to work 9, 10, 11 hours a day just to help the company out. They're not looking out for us, so why should we worry about more than 8 hours work? Not an 8 or 9 or 10 or 11 hour day and go home 11 and a quarter hours so you can be back within the 12-hour intermission, but about a 6-hour day. And there's no more authority in this country than our Vice President, Mr. Nixon, who said that would be the answer to everybody working and keeping work a 30-hour week.
And maybe a shorter work week would alleviate the problem, but that too wouldn't be the answer. The important thing, wherever there's mechanization or automation, is that there must be a corresponding increase in business to take up the slack of work.
Ross Miller, president of the Freihofer Bakery, which incidentally started 80 years ago with a push cart, explains why the push-button bakeries are inevitable.
The real advantage in automation in the baking industry is to produce a softer, fresher, and more perfect product at a lower cost and absorb increased prices of labor and ingredients. I believe that automation will cause some layoffs, but these men will be absorbed in other industries. Today, because of lower costs due to mechanization, we have installed a very liberal pension plan which allows the man to retire at age 65 or in some cases below that age. Today, workers who would have been in our plant working at age 70, 75, or 80 are basking in the sunshine in Florida.
This is an ancient textile mill once operated by American Woolen on the Assabet River in Maynard, Massachusetts. In 1951, it was abandoned, and it was the economist's example of the industrial boom which once built New England and which ended when the textile industry moved south because of economical power and cheaper labor. But today, this building is almost completely occupied by a new industry and has greatly strengthened the town's economy. And it couldn't have happened without automation, as symbolized by this oil refinery operated by Tidewater. This is the classic example of total automation. Purists will say that this kind of chemical plant is the only true automation thus far developed. Unlike Detroit automation, which is a series of highly mechanized steps brought together by an assembly line, this is the continuous processing method in its most advanced form. 88 separate oil tanks connected by thousands of miles of pipe and towers 20 stories high are dominated by a master control room, which silently and efficiently measures every step of this critical process. There are technicians and maintenance men here, but they're dwarfed in this labyrinth of Martian-type towers. An automatic typewriter, fed production data by a computer, translates this information into total inventory every hour on the hour. It is also possible, at any given moment, for the operator to get figures on temperature and the output from any tank in the plant by simply plugging a jack into the switchboard. The plant is practically noiseless, except for the breathing of the high-pressure steam and the whir of the instruments, which count every step, constantly reflecting the amount of fuel in each tank, previously done by literally lowering a measuring line into the tank. This plant produces 2.5 million gallons of gasoline a day and an almost equal quantity of other petroleum products. But automated refineries, such as this, produce a byproduct which has created a vast new employment. This gas, once burned away as waste, can now be processed into a new plastic compound called polyethylene. This is polyethylene, and we're back in that old textile mill in Maynard, Massachusetts. These crystals go into one end of this machine. Seconds later, a plastic tube is extruded. Containers, such as those used for detergents, toilet articles, and pharmaceuticals, complete with four-color printing, come off a conveyor at the rate of 3,000 per hour. This plant was founded 3 years ago by Bradley Dewey, who started with 2 machines and 2 workers. Today, it employs over 800 workers and is owned by the American Can Company. This business and the growing polyethylene industry, which also produces weather balloons, surgical tubes, piping for farm irrigation, could not have existed without automation. The formula for polyethylene, like that of Dacron and the other synthetic fabrics, is so critical that they could not be made without the controls of the automatic chemical plant. We talked with Thomas J. Watson, Jr., chairman of the board, International Business Machines.
Well, now, the word think has been associated with your company for a long time. Is the introduction of these new computers and so forth going to reduce the necessity for thinking?
Well, that's a hard question to answer in a short phrase. It will reduce the requirement for drudgerous, repetitive, non-creative thinking. But it certainly, I think, will increase the opportunity for men to think on the imaginative, creative lines. I'm referring particularly to men who up to this time have been doing repetitive bookkeeping tasks where the ability to create and to think new thoughts, put 2 known thoughts together and come out with a new third thought. So I think a good deal of this human element at the moment is semi-useless. The humans are being used as messenger boys, and we could just as well do that with electric wires when the process becomes sophisticated enough.
Well, are you not worried that as a result of all of these new processes, that the human will be downgraded somewhat in society as a whole?
No, I think quite the opposite will be true, Mr. Murrow. A lot of people call these machines giant brains, and whenever I hear the term, it makes me shudder, because they are giant tools. They're certainly not giant brains. And if you have good tools, you're upgrading man, not downgrading him. But these machines are only tools. They don't enter the thinking process anywhere along the line. They're a tool just like a monkey wrench is a tool. It enables you to do more work, but it doesn't do any of the creative work for you. So that I think the most important thing about the machine is that it can't create, never will be able to create. And if one remembers that they're simply tools like simple monkey wrenches, then I think you can put them in their right perspective in our everyday life. People attribute to computers a good deal more originality than a computer ever had or will have in the future. You know, machines now can add 10-digit numbers piled as high as the Empire State Building and foot up a column of that magnitude in a period of about a half a second. But again, you have to put the numbers into the machine, and the machine simply adds them up and repeats the answer back to you. Nothing original.
What's going to happen to these people who are unemployed or replaced by automation?
Well, first off, I don't visualize great hordes of people being thrown out of work by automation in any given industry or factory. I think the process is a very slow one. I would think that in the application of this sort of equipment that you see here today, that there have been almost no people displaced by the equipment permanently or temporarily, because the machines are complicated enough so that they move in very slowly. And in the process of moving in, the people can be assimilated in other parts of the company that are growing. Computers give a greater precision to the control of the industry, and we hope, and I think in most cases prove, that the result of this control is more sales and lowered cost of product. And if you're making more product, you need more people through the whole process. So these computers sort of justify themselves by speeding up the industry and absorbing the people that they displace.
Are all these computers and other automation devices going to shorten the work week?
I would think so, Mr. Murrow. I think that automation and the use of computers, as you suggested earlier, is really just an extension of the Industrial Revolution. And in the last 100 years, we have seen a shorter, progressively shorter work week, working hours. I would think that though this process at the moment has been slowed down, that it would continue at a slower pace, and we would find American people working an average shorter work week. Though how much shorter and how quickly, again, it would be just a guess for me to try to answer that.
Well, Mr. Watson, if more and more goods are made by fewer and fewer people, who's going to buy the goods?
Well, I think that you will notice that here in America we have an economy based on the consumption of the working man. If none of the wealthy people in this country bought anything after tomorrow evening, it wouldn't make much of an impact on our economy. And as these men get higher wages and are able to buy more real goods with their wages, then I believe that will absorb a good deal of what we produce. For I don't think in the future that our exports are going to build up percentage-wise very greatly. And I think we're going to have to consume in the United States most of what we produce here. So the consumption is going to be American consumption. I think with the standard of living increase that we're now experiencing in the United States, that the average American has a lot more things he would like to have, provided he has the money to buy them with, or provided the prices are lower so that he can buy them with his presently available funds. I might say that recently in Italy, after a full day's debate on the part of some 24 different nations about what automation was going to do to Europe and the common market, and with great optimism for the use of automation, an Italian by the name of Pirelli, who was head of a large rubber company in Italy, stood up before the audience and said, let's remember that automation is a process caused and governed by man. And let's never forget the man in the proposition. Man is created automation, man uses it, man benefits by it, and he closed by suggesting that we as humans shouldn't get the lights in the streets so bright that we couldn't see the stars. I liked it.
So do I. Thank you very much, Mr. Watson.
Thank you, Mr. Murrow.
No responsible person in management or labor contends that automation can or should be stopped. But what if it could? What about the rest of the world? Nevin Bean, a top Ford engineer, was a member of a U.S. delegation that saw automation in the Soviet Union. He was impressed.
There's one thing, Mr. Murrow, that I would like to show you that we saw in Russia. We went into the Kaganovich ball bearing plant, and we were shown one line where they have applied complete automation. They make a roller bearing on this line, and that roller bearing has an inner and an outer race. It has the rollers held in place with a retainer. Now, these races are put into a hopper. They are hot-rolled forgings, and they're metered out of this hopper into a turning machine, which we call an automatic chucker. It does rough machining. From here, it's transferred automatically down to some machines where it semi-finishes, and then down to another battery of machines where the precision machining operations are performed. It crosses over an aisle and goes into a continuous heat-treating furnace. The bearing came out of this furnace, slid down into a quench tank, and then up a mesh belt where the quenched liquid was blown off and partially dried, and then it went into a battery of grinding machines. Now, there were quite a few of these grinding machines that ground the inside diameters, the outside diameters, and the faces. And after each grinding operation, there was an automatic gauge
that would check the quality of the operation just performed, and then it would automatically go on to the next operation. This continued until all the grinding operations were complete. Now, when the inner and outer races were ground, they converged to a focal point here, and the rollers were assembled into a retainer. Then the cone would come along face up. This assembled retainer would fall over the cone, and then the outer race would fall over that. When we unpacked our box and picked the bearing out, we were the first ones to handle that bearing. Ours were the first human hands to touch that product. Now, I was conducted through a similar plant in this country, and I was very much impressed with what I saw here. I visited one of our larger bearing plants, and they had automation there that was really a credit to an engineering organization. However, I have made the statement previously that from a visual standpoint, from looking at it, without any measurement of efficiency, the setup that we saw in Russia is about as good as any application of automation I have ever seen. It was an exceptionally well-engineered, well-built, and well-producing unit.
Well, as I understand it, in the field of automation and machine tools, in some areas the Russians are 30 years behind us, in some they're about even, and in certain areas they may even be ahead.
Well, I believe that the Soviet Union is much more interested in automation than we appear to be here. And if the plans that we saw in development there are carried out, they'll make great production strides and great industrial strides in the next 5 years. I would say in 10 years that they will equal in many cases the progress that we have attained here. And I believe that a prediction is quite in order to say that if we do not put an added stress on the necessity for automation here, that in 15 years they may be ahead of us in many lines.
Well, does that mean that it's possible that they could outproduce us? I mean, particularly in the field of machine tools?
Russia produced about 105,000 machine tools in 1955 against approximately 88,000 produced in the United States in 1955. I believe this substantiates some of the statements that I made after returning from Russia.
Out in Detroit, we talked with Walter Reuther, Executive Vice President of the AFL-CIO and President of the United Auto Workers.
Let's begin with a simple question. What has automation done, and what is it going to do to the automobile industry?
Well, I think I can say, Ed, that automation has already had some impact upon the employment opportunities in the automotive industry. Based upon the best figures that we can get, we've lost roughly about 150,000 jobs during the last 9 years. But I think we need to understand that automation really is just in its infancy, that we've just begun this whole mechanization of the manufacturing and assembly processes, and that essentially we're sort of standing on the threshold of the second industrial revolution. I have great confidence in the future. I personally believe that if we work at the problem, I know that we can solve the problems. What I'm frightened of is that maybe people will believe that we can just coast. There are certain industry people who've got the notion that automation is not the beginning of the second phase of the Industrial Revolution. They say it's just an extension of the old technology. Now, that is not true. That's really a running away from reality.
Well, what's going to happen to the men who are displaced by the machines?
Well, this is the big problem. And I don't believe that we can truly measure the impact of automation upon the displacement of labor yet, because it's too early. But certainly, based upon what has already happened, this will become an increasingly serious problem unless we begin to project plans into the future. Now, many things have got to be done. Obviously, we've got to retrain workers so that they can be absorbed at new skills as automation changes the character and the composition and the requirements of each job. But all of this thing will require some advanced planning. And one of the things that concerns us at the present time is that there is no place where we can get a total look as to what is happening to the American economy in terms of the long pull. General Motors knows about the automotive industry. General Electric knows about the electrical industry. The Standard Oil Company knows about petroleum. DuPont knows about chemical. But no one, there is no place now in the United States where anyone has pulled together all of the threads of this problem and try to weave it into a total pattern. And what we've been suggesting is that free labor and free management in cooperation with free government ought to create some sort of a technological clearinghouse where there could be a central place where we could assemble all of the data, what is happening today, what we can project for tomorrow, what we can think about beyond tomorrow, so that as a rational process, we can begin to know the facts and then begin to plan as free people to meet the problems and to realize the promise of the greater abundance that these machines will make possible.
Well, then, you're not suggesting that the government should decide, but that it should be a cooperative venture between government, labor, and management.
Yes, the government would essentially provide the mechanics by which the voluntary groups using those mechanics would make voluntary decisions. When the most complicated tool was a hoe, it didn't matter whether the person who owned that hoe used it responsibly or irresponsibly. It had no impact upon society. Maybe the family of the person who owned that hoe wouldn't eat as well. But as the technology and the tools of production become complex and more productive, the ownership of those tools takes on broad responsibilities. Labor, since its decisions have an impact upon the use of those tools, labor takes on new responsibilities.
Well, do you think the 4-day week is just over the horizon?
I think the 4-day week will be with us much quicker than we realize, because I believe that the impact of automation and atomic energy and these other new technologies is going to come much faster. And you cannot measure the future by the standards of the past, because this whole process is going to be accelerated a great deal. And that's why I believe that we will get the 4-day week long before we can use it intelligently, unless we begin to work hard now on how can people use their new leisure creatively and constructively. That's the problem, I think, that needs a great deal of attention, because that's the area. This, again, you see, is this lag between in the social sciences as compared to the physical sciences. We always make more progress in working with machines than we do with men. As we automate production, the individual worker gets further and further removed in the production processes from the ultimate end product. I mean, a worker makes a Cadillac, but he doesn't have any feeling that he helped create that, his little pieces. And we've got to find a way in the leisure hours of people to give them an opportunity for personal creative expression. And this is, I think, the great challenge. We can feed and clothe and house and take care of man's material needs. But having done that, we ought to find a way to enable people to grow into better human beings by enabling them to grow and mature and develop culturally and spiritually and intellectually.
More hospitals, more schools, more recreation facilities.
These are the things we need to put greater and greater. I think we've got to rearrange our priorities. We've got to somehow get our values in sharper and clearer focus so that we know precisely really what are we trying to do. I happen to believe that if we're just in a race with the communists to see who can achieve the greatest material prosperity, just in terms of bathtubs and plumbing and radios and TV, I don't think we have any assurance the Russians can't do a job equally, if not better. They've got to be behind this great material prosperity, a kind of a sense of moral purpose, because power without morality is power without purpose. And it's in these terms of these intangible, basic human values that I think the free world has to maintain its margin of superiority over the communists. And I believe that here again, that if we can approach this in terms of the economics of abundance, instead of the economics of scarcity, we can solve our problems. But the tragedy is, too often people always think in terms of dividing up scarcity, when we ought to be thinking about how we can cooperate to create and share abundance.
The ancient pyramids of Egypt, although regarded in their time and ours as one of the 7 wonders of the world, were built by slave labor. The true advocates of automation today claim that our civilization is guilty of intellectual pyramid building in the way we run our offices and bureaus, that the Egyptians harnessed hundreds of thousands of slaves to build mountains of stone, and we enslave hundreds of thousands of office workers to build mountains of paper. America may be a nation on wheels, But as a nation, we live on paper. We shuffle it, collate it, staple it, multiply it, post it, digest it, file it, and sign it, and generally in quintuplicate. The red tape will probably always be with us, but magnetic tape and computers are beginning to process it. This roll of tape contains all of the weekly payroll data of the 32,000 employees at General Electric's Schenectady plant. Instead of sending the 900 sheets of paper, complete with hours, pay rate, Social Security, bonds, and other deductions, this single roll of tape is sent quarterly to Social Security in Baltimore. A second tape is used to make up the payroll. It directs the writing of checks at the rate of 70 per minute, and another gadget signs them at the rate of 200 a minute. All of this is designed to free men and women from the drudgery and monotony of pushing papers. The human machine, Norbert Wiener of MIT says, is too complicated for such tasks. For tasks like pasting labels on tin cans or sorting spears of asparagus or tightening one or two bolts on a Detroit assembly line. It is, he says, degrading to chain a human being to an oar and use him as a source of power. But it is almost equally degrading to assign him a purely repetitive task in a factory which demands less than 1/1,000,000th of his brain capacity. But what about the woman who said she'd rather sort asparagus or shuffle papers than be replaced by a machine? What about the worker who said he'd rather tighten a bolt all day than not eat? Certainly, only an industrial Pollyanna would say that automation is not going to cause some displacement, even some unemployment. But there is much evidence to support the belief that automation will actually increase the number of jobs needed to keep up with our production requirements. We have all kinds of new jobs because we have all kinds of new industries, and automation itself has, since World War II, become a major employer. By 1960, it is expected to reach a $7 billion volume. The Cross Company of Detroit, where we are now, makes much of the automation equipment for the automobile industry. The company has tripled itself in the last 5 years, makes $15 million worth of automation equipment a year. Ford's first automated cylinder block line cost $9 million. This new one will cost considerably less. Plymouth's new automatic assembly line cost $2.5 million. Some industries may never really automate because the cost is often prohibitive. The computer and instrument phase of automation is still the fastest growing. International Business Machines does $892 million a year, much of it in computers. Turns out 1 computer a day. Remington Rand has already produced 60 UNIVAC, has orders for many more at $1 million to $1.5 million per unit. Employment figures at these companies and at Burroughs, RCA, and Minneapolis Honeywell, among others, have increased to the point where some economists claim that automation equipment may one day account for as much employment as steel or automobiles. The Minnesota Mining and Manufacturing Company, which makes the majority of the tapes upon which so much of automation depends, has more than quadrupled its sales in the past decade, expects a $375 million year for 1957, employs more than 19,000 people. They coat tape with magnetized iron oxide. In much the same manner, they coat their Scotch tape with stickum, and then split it into 1/4 inch, 1/2 inch, and other required widths. Such tape, in addition to programming jet stabilizers and making up payrolls, can record both the picture and sound of television shows, program radio stations for an entire day, or fly a guided missile. It has been predicted that by 1960, 10% of the products manufactured may consist of items not yet on the market. Chemicals as high as 16%. Electrical products, 18%. And much of this may well be produced by companies that did not even exist 10 years ago. Out in Columbus, Ohio in 1951, 3 veterans, all under 30 years of age, combined peacetime use of the atom and electronics to set up the Industrial Nucleonics Corporation. They manufacture the Accuray device we saw in that steel mill and have sold similar feedback control systems to more than 200 manufacturers, including Goodyear, International Paper, Liggett & Myers, and United States Steel. Expected sales this year, $8 million. Employs more than 350 people, including 125 highly trained engineers who know they cannot afford to stop learning. One of the outstanding authorities on automation and cybernetics is Professor Gordon S. Brown, Massachusetts Institute of Technology. Ed Scott asked him about the future.
Automation is not the third industrial revolution. It's a wholly new kind of revolution. It's an intellectual revolution. I think the human being has to become smarter. He has to be better educated. But I know he can become smarter because he's becoming better educated. Educated man today must have a balanced understanding of the fundamentals of the life sciences, the social sciences, and the physical sciences. Now, this is not easy to bring about because you and I weren't brought up to know this. So it's a new generation of people that must constantly take over. And I'd just like to throw in a word here on a very important topic of the day. I read it in this morning's newspaper about needing more monies for education. I would like to make sure that we measure these costs not in terms of dollars, because that's a rather elastic, or shall I say, a rubber standard. Measure it in terms of human labor, human effort. And if you and I just stop for a moment and reflect, we can easily compute that in spite of the high cost of sending our children to our schools and our local communities in terms of dollars, you and I both work fewer hours today to earn the money to send them for this better education than your father and my father had to work to send you or me. So actually, in terms of human effort, the cost of education has come down. It hasn't gone up.
Dr. Brown, is there any danger, in your opinion, that the machine will replace manpower?
No, I don't think, to generalize, there's any danger that a machine will replace man, but I think man would love to see a machine replace him in a lot of day-by-day occupations. There will be change because man seeks to be substituted by a machine. He doesn't want to go into these unhealthy, degrading, disagreeable environments. He doesn't want to go underground to dig coal, for example, any more than he wants to live in a dirty, smoky, uncomfortable environment. Now, this we all welcome. The basic problem is to realize that if it comes about because of technology, it probably is going to be better understood by the young person than the old person. We say that it's a young man's game, but the oldsters still need to play. Therefore, we need to have an intelligent, organized procedure for re-educating us all as this inevitable change comes about. Now, the working man doesn't need to feel that he's the only person affected by this. Because let me assure you that college professors today, even in engineering, have to retool themselves in order to teach the right kind of technical material to their students every 2 or 3 years. And the whole history of technology is that never has man devised a machine which within a few years hasn't been called upon to perform tasks that overtax the ability that the designer built into it. This, in turn, you see, means that the designer has to tackle the redesign to bring about greater performance, greater productivity. And even the mathematician is not freed from this hazard of, shall we say, technical obsolescence. Because as the great computers have been made available to the mathematician to solve a lot of his mathematical problems, it hasn't freed the mathematician from the need to know mathematics. On the contrary, it's necessitated now that he really know mathematics such as he never thought he would have to know it before. Now, this isn't anything to be afraid of, because as you present these challenges to the human being, they love it. This is what man, you see, intellectually was, I think, destined to become. But in order that we bring this about, you and I both need to know that the challenge before us is an intellectual challenge. For as we move in the direction of exploiting science for the benefit of mankind via automation, we inevitably, in this process of substituting machine for muscle, machine for certain items of human drudgery, we will inevitably end up with an economy that will be more complicated, require more intellectual ability to keep it running. And as we proceed with the task of mastering it, as we will, we'll have to come up with new ideas about how we work one with another, new ideas in terms of the values of human conduct, and a better and more harmonious marriage between government, labor, management, and John Q. citizen. I think the future is terrific. I wish I was going to live for another 100 years.
In considerably less than 100 years, the stretching fingertips of science will have uncovered new horizons and new problems. The prospect seems to be for less drudgery. At the same time, more need to know. We have no monopoly of know-how. The Russians are turning out more scientists and engineers than we are. Right now, we are short 200,000 teachers. 23% of our high schools offer no chemistry and no physics. 24% of them no geometry. It may well be that our most urgent problem is in the field of education. Maybe we have overestimated these miraculous machines. They cannot tell us the difference between right and wrong, between good and evil. They cannot produce a formula for compassion or for tolerance. They can save us from drudgery to a certain extent, but they cannot save us from the need to know. There is no conscience in a computer, and the speed of communications does not necessarily add merit or importance to what is communicated. Every foreigner almost who has visited this country and studied it carefully has remarked that one of the hallmarks of this nation is our genius for cooperation, the ability to work together. It may be that that genius is now about to be tested as never before. At least we have found no machine breakers in our researches. There seems to be a widespread determination to use these new devices for the welfare of society as a whole.